Good evening, ma'am. This is my presentation for the Python pattern program. So first, my program asks for a number from 1 to 9. So just to mimic the reference image, I'm gonna use 5. So after that, it will basically ask for certain options. So we have reset, we have the ability to change the number range. We have all of the different we have the different patterns, and then we have generate all patterns. So for the sake of brevity, I will be generating all patterns. So as you can see, it matches the so here parallelogram, triangle, uh, the diamond, and then the hourglass. So if you're wondering why pattern 5 is a different diamond, so I kind of had to change the code specifically just to kind of I have to change like a little bit of how it will display just so that it kind of works with how number 5 will how it will like use the user input, so it will be just stuck between 1 to 5. Pero to completely mimic the reference image, I can show that right now. We'll reset the input to 7, and then I will simply show it as the diamond. So button 6. There you go. Alright, so here we go. So this is exactly like the reference image, 1 to 7, and then 2, 3, 4, and 5 and 6. So that's pretty much it. So I can just quickly show each separate input. 2, 3, 4, 5, 6, 7, all of it, and then finally to close the program we have 9. So that's it. So I'll quickly go over the code. So first of all, let's go quickly to the main input. So here we have the pattern generator. Here we have num range. So this is the range. So we declare it, and then we call to a function. I'll explain that later to generate the range. So here we have basically the basic menu. So the choice, and then this basically checks if the choice is numeric. So the reason why we have strip here is just to remove the extra spaces, because I had an issue with, because the way it works is that the input is a string, so regardless of what you put, it will always have the empty space. And the problem with is numeric is that it takes the string and basically checks if all of the characters in that string are integers. And the problem is that the space, the accidental spaces that you can put before an input counts as a non-integer variable. So even if you put 5, if you put a space in front of 5, it will basically see it as a string. And so that's why we need the strip to remove all of the white spaces so you can actually validate the input. So is numeric basically just checks if the output itself is numeric, is a number. So obviously please enter a valid option. So of course you validate the user's choice. We basically we change if it is a numerical number, it will basically change, it will force the type, the data type into an integer. And then here, we're just rechecking it to see whether it conforms with if it's actually a valid number, if it's within the range of options that are presented to them. And of course here we have an if else for basically every single possibility. So we have one for the generate range, the same one we saw before. We have one for each of the different patterns, and then we have one for all the patterns, terminate program, and then an else just in case if there's an error. So let's go through the actual functions. So here we have generate range. So here there's a while true. So basically just to keep on going, and accept user input. So here, this is where we actually ask, whether you want to generate number from 1 to 5. We have the strip, so we do the same kind of check earlier from user input, and then is numeric, practically the same. And then it will basically create a range. We use a for loop. We use the range to create it iterates from 0 to the user input, and then for every number that increases, we append that to the array. And the reason why we put number plus one is because we count from zero, so we have to put one. So we actually start with the value one. So the value one in the start of the array would be 1 2 3 4 5 instead of 0 1 2 3 4 5, and then we simply return the range that was generated, and we give it to the main function. So left curve is for pattern one. So it's the first pattern that we saw. It's kind of it's self-explanatory. It's the left curve. So the way it works is, so we basically iterate through number range, and then for every one for e- for so we basically nest another loop within it. And so I will quickly explain this. So um we're basically using a slicing function here. So the its syntax is, it has like three parameters. The first one is the start, the second one is the stop, and the third one is the step. So here, since there's no second colon, and there's and the variable is within the right side of the singular colon, so this is the stop. So basically what we are telling is that, uh, in this number range, essentially we're basically iterating upon number range, but we stop at this counter. So we stop at this number, and the number is counter. So the way this will work is that, okay, so for counter in num range, so that will, let's say, be number one. So basically this will iterate until it will basically iterate until we reach, I think, index, or not. Yeah, no, we until we iterate until we find index 1, and we'll stop. And then after that, it will just simply print. It'll simply print the what call that it'll simply print the the display. So like the variable that is set here, and then after that it will print out the pattern, and then it will set pattern back to, to an empty to an what call that, to an empty string. And so we repeat the process until we basically get 1 2 2 3 3 4 4, and so on. So for the other section, since it's a curve, we simply do the same thing. We have the same function, but this time we use reversed. So what reverse does is that it is a function where it takes in a parameter, basically a list. So like the list of the range here, and what it does is that it iterates through that list. So it doesn't really do anything to the list. It simply just counts backwards. So it takes the list, doesn't do anything, it doesn't create a new object, and it will just go from, instead of 1 2 3 4 5, it will just go 5 4 3 2 1. And that's basically how we kind of reverse the iteration. So for right curve, okay, so I'll be opening a bit of a reference here. So for right curve here, so for the top section, and also for the bottom section, so this just encapsulates it. So what we're gonna do here is that we're gonna add another for loop to that. So it's kind of like the same idea, but here we're gonna add another for loop, which is the white space. So as we can see here, before we display number one, there is actually a bit of an area here. And as you can see, you can plot it out as this, this random boxes here. So if you actually do the math, so for example, let's say the first one is on number one, and then we iterate up to 4. So that would mean that it would max out at at 4 blocks, and then number one would have 3 empty strings. So what we can do is actually take the maximum number of the maximum rate the amount what's the word basically we take the maximum range, right? We take whatever there we go, the length of the maximum range, and then we subtract it with the current number, or the current counter. So here we have 1, we have the, let's say, the maximum range is 4. So if the current counter is 1, so 4 minus by 1, that would be 3 boxes. So we iterate back to 2, and then after that, we take 4 minus by 2, so we have 4 empty boxes, and so on and so forth, until we basically you can basically fill in this space. So the reason why we want to do that is we basically want to iterate. We basically want to iterate on the on that range, and we basically so here we have pattern plus equal. So here we have an empty pattern, and so we, depending on the number, depending on this calculation, like how many white spaces do we need, it will basically keep adding this empty space into that pattern, and then once it's done, we simply do the regular display pattern, and that's how we do this 1 2 3 and then display, and then 1 2 display 1, and then display, and so on and so forth. And so for this, practically the same thing. We just do the same thing, but with the reverse function, so that we can do it in reverse. And that's pretty much it. That's pretty much it for the second pattern. For the third pattern, it's a parallelogram. So as you can see, what we did here is we basically just took the first iteration of left curve, and then we put the second iteration of here we put the second iteration of right curve, so that it does this, it kind of forms this parallelogram shape. Oops, like that. It has this type of shape. So if you kind of angle it a bit, it does feel like a bit of a parallelogram right there. So that's a third. So that's, oh sorry, here. So that's the third pattern. The fourth pattern is the triangle. So the triangle is an interesting one because it isn't just 1 2 2 2 2 3 3 3 3. It's actually 1 and then 1 2 1 and then 1 2 3 2 1. And so the way we do this here is that, okay, so as you can see here, we don't just have pattern, we have previous numbers. So okay, so as you can see, there's still a white space counter. There is the display for, where is it? So we have the plus equal white space, we have add string number, and so on and so forth. So it's basically the same concepts we used before, so I'm not really going to discuss them, since they're practically just the same idea but executed differently. So I'll just focus on like the kind of bigger structure here. So the bigger structure is, we have once again, we have the maximum we have the maximum, like the num range, the max number. We have counter, just to like iterate throughout the array. And then here we have a new empty array called previous numbers. So previous numbers is gonna store all the previous numbers that we basically iterate across. So first, let's go to 1, right? So, oops. Give me a moment. So what we do is that the moment we iterate, right, we're basically, we're gonna do the white space thing. We're gonna calculate the num range minus by the counter, and then we're gonna add it here, and so on and so forth. And then what we're gonna do after that is done is, as you can see here, pattern is equal to pattern plus by the string counter plus pattern. I will explain this, but essentially what we're doing is that we're basically splitting this into three sections. So what happens is that all this empty space, or basically anything, so this is the current counter, right? So from 1 2 3, so you can imagine the middle section as the current counter. So the current counter is 1 2 3 and 4. This side, you can think of it as basically the white space and the previous